Our topic is CPU scheduling. Already we discussed this word called scheduling. Okay. So when we use the word scheduling, one processor, okay, one processor is there. More number of processes are there. P1, P2, P3, P4, like that. So many processes are there. Pn. Only one CPU or only one process is there. Now, how to schedule this process so that all will get to the CPU? Okay, how to schedule this process? How when P1 will get processor, when P2 will get processor. So scheduling the processes to get to the processor is a CPU scheduling. Okay, so what are the or at what situations CPU scheduling is required? Okay, at what situation CPU scheduling is required? First one, running to wait state. Already we know about the states. Okay, process states, I think. What are the states you remember? New state, ready to run state, wait state, running state, and exit state. Five states are there. Okay. So when a process is moving from running to wait state, from wait state, it requires scheduling. Okay. Consider this is CPU. CPU la process P1 is in execution. Due to some incidents, P1 is going to waiting state. Okay, now P1 is waiting. Now what CPU will do? CPU will work with the other process. So process P2 have to be scheduled. Okay, process P2 have to be scheduled. That is one option. Another option, process P1 will complete its work. Okay, process P1, it completes its work, and that process was moved to ready to run, and from ready to run also it is going to execution state, running state. At that time also scheduling is required. Okay, the first situation is when it is running to wait state, some other process have to be allocated. At that time scheduling is required. One situation. Second situation, running to ready state. When it will go to running to ready state, already we have discussed in the state various different states, process states diagram. Okay, so now P1 is running. Instead of wait, it is going to ready state due to some interrupt. Now CPU is free. At that time also scheduling is required. Waiting to ready. So from waiting, as I told, okay, from waiting state, process P1 has completed its input-output requirement or interrupt is handled successfully. Now waiting to ready state, it is coming. Now process is in ready state. Okay, process P1, P2 are in ready state. Now also it requires scheduling. P1 has to be scheduled, P2 has to be scheduled because both are not yet completed. Still, it requires CPU to complete when the process terminates. Okay, process P1 has completed its work completely or comfortably. Now new job has to be scheduled. Okay, to say it simply, whenever CPU is free, it requires scheduling. That's all. Okay, assume your entire system is having only one process. There is no concept of scheduling. If there are more than one process, 10 processes are there, all wants a CPU, at that time scheduling is required. When scheduling will be performed, whenever CPU becomes free, scheduling will be performed. That's all. Okay. So here we have to understand two important terms called CPU burst and IO burst. The burst means time taken by the process to be available in CPU, that is CPU burst. Okay, that means what? Process P1, CPU burst time is, for example, 10 seconds. What does it mean? Process P1 wants maximum 10 seconds to be executed in the CPU. That's all. Okay, CPU burst means what? The time required by the process P1 to be spent in CPU. Okay, another 10 seconds, maybe IO device. Another 10 seconds, maybe in main memory. Another 10 seconds to get input. All those time we will not consider. A particular process spent how much time exactly in the CPU, maximum time. Okay, so what does it mean? CPU process P1, CPU burst time is 10 means The time required by process P1 to be spent at CPU at the maximum. Okay, maximum it requires 10 seconds to be executed in CPU. Okay, like that IO burst also. Okay, time required by the process to be spent in either input or output. Able to understand? Okay, CPU burst and IPU burst. IO burst. Okay. Another two important terms you know or you should know is preemptive and non-preemptive. I think you would have discussed in architecture. Anyway, one more time. Preemptive and non-preemptive. Suppose assume some process is executing in CPU P1. Okay, P1 requires maximum 10 seconds to complete its work in the CPU. So P1 OS has allotted 10 seconds to execute. Okay. After 2 seconds, another process P2 is coming, which says operating system, I want some urgent work to be done, so give me the CPU. Okay, I think you are able to understand. OS has allocated P1 to be executed in CPU. So P1 has started its work. Total allotted time is 10 seconds. But after 2 seconds, another process P2 is coming and asking OS, I want the CPU very urgently, kindly help me. Now OS decides to give the processor or CPU and terminates process P1. This is what we are referring as preemptive. That means current process can be suspended because of any other external process. Okay, if we allow a current process that is in CPU to be terminated, instead of allocating or in the place we are allocating some other process that is called preemptive. Okay, premature, like that we used to tell, no, like that preemptive. That means their allotted time is not yet over, even though we are terminating the process. We means operating system. Okay, non-preemptive means once process P1 is allocated CPU for 10 seconds, for next 10 seconds P1 will not get suspended. Okay, by any means, whatever may be the situation. If it supports non-preemptive means once a particular process allotted the CPU, it can come out only after 10 seconds. Okay, only after 10 seconds. So preemptive means current process can be suspended. Non-preemptive means current process cannot be suspended until its completion. Okay. So what is the criteria we are going to use for scheduling purpose? We are going to discuss CPU scheduling. What are the criteria to be considered to get the better CPU scheduling algorithm? Okay. CPU utilization, of course, we used to know what is CPU utilization. Then throughput. What do you mean by throughput? I hope everybody knows about this term called throughput. Okay. Number of jobs completed in a period of time or in a unit time. For example, number of jobs completed in 10 seconds, number of jobs completed in 20 seconds. That is throughput. Okay, so throughput equal to 5 means what? 5 jobs have been completed in 2 seconds. The throughput is 2. Okay, turnaround time. Okay, turnaround time. Time taken by a particular process between its arrival and the completion. Okay, arrival means ready queue. Ready queue means main memory. Okay, ready queue is there. Okay, so already process P1 and P2 and P3 is there already in the queue. Process P1, P2, P3 is there. Now assume process P4 is coming to the queue at 10 o'clock. Okay, process P4 is arriving at the queue. Okay, ready queue at 10 o'clock. And the process P4 has completed its work at 10:30. The turnaround time is 30 seconds or 30 minutes. Okay, assume the minutes means 30 minutes. Turnaround time of process P4 is 30 minutes. Okay, or 30 seconds, whatever it may be. Are you able to understand? That is turnaround time. Okay. What is waiting time? Okay, waiting time means the time taken by a particular process when they are in the queue. Okay, not in CPU. Okay, one small example I am telling. Listen carefully. Okay, I'm taking only one process. For better example, I'm taking only one process. Okay, process P1 is coming to queue at 10 o'clock. Okay, process P1 is coming at queue at 10 o'clock. And now OS is seeing CPU is free or not. CPU is free. So P1 is entering into the CPU at 10 o'clock. What is the waiting time for P1 at present? 0. Because P1 is not at all waiting for any time. When it is coming to ready queue, the CPU is free. So immediately P1 is allotted the CPU. So there is no waiting time for CPU at present. Okay. CPU order, sorry, P1 order CPU burst time is 20 seconds. That means what? P1 requires a maximum of 20 seconds to be spent at CPU. Okay. Now after 5 seconds, at 10:05, okay, after 5 seconds, P1 is suspended, that is preempted for some reason, and that is placed in queue. Okay, running to ready queue. P1 is suspended for some reason by OS and it is going to ready queue. Okay, reticular, it is waiting for 5 seconds. Okay, reticular, it is waiting for 5 seconds. That becomes 10:10. So after 5 seconds, CPU is free. Now P1 is allotted the CPU. Now P1 is coming here. Now P1 is in execution. Okay, after 3 seconds, it is getting suspended. That is 10:13. Again, it is getting suspended and it is moving back to queue P1. Okay, now so far, what is the waiting time for P1? Here it is 0. Okay, 5 seconds it is executing. QL, how much time it is residing? 5 seconds. So here it is waiting for 5 seconds. Then again after 3 minutes it is coming back to P1. So now assume after 10 2 seconds, 10, 15. Now CPU is free. Again it is allocated the CPU. So here it is waiting for 2 seconds. Then after remaining time, P1 has completed its work. Now what is the waiting time? Here 5 seconds and here 2 seconds. So total waiting time for P1 is 7 seconds. Okay. So the job is completed at job is completed at 10:27. What is the turnaround time? What is the turnaround time? 10 o'clock it is coming, completed at 10:27. Turnaround time is 27 seconds. What is the waiting time? 7 seconds. What is the burst time? 20 seconds. Okay. Upon turnaround time oda formula enna? Turnaround time equal to CPU burst time plus waiting time. That's all. Okay. Turnaround time equal to CPU burst time and waiting time. How much time it is requiring CPU and how much time it is waiting. Total time adan turnaround time அப்படின்னு சொல்றோம். Okay, waiting time I have already discussed. Okay, waiting time oda formula enna? Completion time minus CPU burst time. Okay, completion time minus CPU burst time we will see in the. Okay, as I told, waiting time means total time taken by the process not in CPU. Okay, when it is in CPU, that time should not be considered. When it is in not CPU, that is when it is in queue, that time we have to consider after its arrival. So note down this waiting time formula. Waiting time equal to turnaround time minus burst time, CPU burst time. Okay, waiting time equal to turnaround time minus burst time. Burst time na enna? Time spent in CPU only. Now formula for turnaround time. Turnaround time and time between its arrival and its completion, as I told. So turnaround time formula, burst time plus waiting time. Okay, burst time plus waiting time. Or in other words, turnaround time equal to exit time, completion time minus arrival time. That's all. Both are same. Completion time minus arrival